All right, this is lesson 5, zeros of polynomial functions. And our lesson essential question is, how are the zeros of a polynomial function related to an equation and graph of the function? Here's our table of contents. Use zeros to graph a polynomial function. What are the zeros of f of x equals x times x minus 5 times x plus 4? Graph the function. A zero of a polynomial function is a value for which the function is equal to 0. By the zero product property, the zeros of the function are -4, 0, and 5. And we achieved those by setting each of these terms equal to 0 and solving them. So x equals 0, x minus 5 equals 0 gave us the positive 5, and x plus 4 equals 0 gave us x equals -4. The zeros divide a number line into 4 intervals. Okay, so we have the values that are smaller than -4, the values that are between -4 and 0, and the values that are between 0 and 5, and values that are greater than 5. To see how the graph of the function behaves on each interval, I look at the sign of each factor on each interval and the sign of the product. So what that means is I'm going to pick a number that is less than -4. In this case, I'm going to pick -5 because that's a value that is less than -4. So if I put -5 in here, my sign is going to be negative. If I put -5 in for x minus 5, -5 minus 5 is -10, so my sign is negative. If I put negative x or -5 in for x plus 4, I also get a negative. So a negative times a negative is a positive. Positive times a negative is a negative. We can do the same thing for a number between -4 and 0. I'm going to pick -2. -2 in for x just gives me a negative number. -2 minus 5 also gives me a negative number. -2 plus 4 gives me a positive 2, so that's a positive. So a negative times a negative is a positive, times a positive gives me a positive. You do the same thing for 0 to 5. So if I pick 1, that gives me a positive. 1 minus 5 is negative. 1 plus 4 is a positive. A positive times a positive gives me a negative. Okay? And I can do it for my last interval, so a number that's bigger than 5. So I can pick 6, I can pick 7, I can pick 8, 9, 10, pick any number that you want, as long as it's bigger than 5. Okay? So if I choose 6, 6 is positive, 6 minus 5 is positive, and 6 plus 4 is positive. Okay? So if I multiply positive times a positive times a positive, I get a positive. Okay? These products are what is ultimately important when I'm dealing with graphing this polynomial function. So I'm looking at the places where they're going to cross the x-axis, which is those zeros. So again, it's 0, -4, and 5. The product of these tells me if it's going to be below or above the x-axis. So I'm going to go below the x-axis until I get to -4. I'm above the x-axis between -4 and 0. I'm below the x-axis between 0 and 5, and then I'm above the x-axis for 5. Okay. So I can sketch the graph, draw a continuous curve that passes through each 0 on the x-axis and is below the x-axis when the function is negative and above the x-axis when the function is positive. Okay. So again, we can see that it's below when it's negative, above when it's positive, below when it's negative, above when it's positive. Understand how a multiple 0 can affect a graph. A multiplicity of 0 of a polynomial function is the number of times its related factor appears in the factored form of the polynomial. Notice the behavior of each graph as it approaches the x-axis. What can you conclude about the multiplicity of a 0 and its effect on the graph of the function? So if I had something like x minus 1 times x plus 2. So I have these zeros, okay? Notice I have nothing that's doubled or raised to any power, and it's going to pass through the x-axis both times. Okay. Now, if I had something like x minus 1 squared, what I'm really saying is x minus 1 times x minus 1 times x plus 2. So I have 2x minus 1. That multiplicity, so I have a multiplicity of 2 at x equals 1 tells me I'm going to bounce off the x-axis, okay, and go back in the same direction that I came in. So I'm not crossing through the x-axis. I bounced off with that multiplicity. Notice the x plus 2 is not raised to a multiplicity. Okay, so it crosses through that x-axis. You can see this again with the x minus 1 cubed, or x minus 1 times x minus 1 times x minus 1. It's an odd multiplicity because there's 3 of them. It's still going to pass through the x-axis at x equals 1. But if I have x minus 1 to the 4th power, that's an even multiplicity, which means I'm going to bounce off. So when the multiplicity of a 0 is odd, the function crosses the x-axis. When the multiplicity of a 0 is even, the graph has a turning point at the x-axis, or it bounces off the x-axis. Find real and complex zeros. What are all the real and complex zeros of the polynomial function shown in the graph? So if I'm looking at this graph, x cubed minus 3x squared minus 2x plus 4, I cross at 1. I can see that I cross at 1. Okay, so that means that there is an odd multiplicity. I can also see that I cross the axis 2 more times, but they're not necessarily at an even number or an integer or a whole number that I can easily look at and say, oh, it crosses at that point. But it does look like it crosses at 1. So I'm going to use the graph to determine one of the zeros of the polynomial. Sometimes they may have more, but at least looking at it, it looks like there is at least 1 0 at x equals 1. So the function appears to cross the x-axis at x equals 1. I'm going to confirm that by substituting 1 in for x in this function. So 1 cubed minus 1 squared minus 2 times 1 plus 4. Okay, so 1 cubed is 1. 3 times 1 squared is negative 3. 2 times 1 is negative 2, and then 4. Okay, 1 minus 3 minus 2 plus 4 gives me f of 1 equals 0. So this is a 0 of the function. Remember when we went back to the previous lesson, when I substituted a 0 in, I would get 0 as a remainder, which means it touches or crosses at that point. I can use synthetic division to factor the polynomial. You can use long division if you want, or you can use synthetic. Either way will work. Okay, so I'm going to factor the polynomial because this is an x cubed. So this makes it more difficult to factor. You can factor it, but it's going to take you a little bit longer to figure out what times what gives you this polynomial. Okay, it doesn't matter which 0 you use first. So if you have more than 1 0, you can use whichever 0 you want. Okay, you'll get the same result in the end. So I'm going to use the 0 that I know, which is 1. So I put 1 in. I have my coefficients set up at the top, 1, negative 3, negative 2, and 4. I bring down my 1. 1 times 1 is 1. Negative 3 times 1 is negative 2. Negative 2 times 1 is negative 2. Negative 2 plus negative 2 is negative 4. 1 times negative 4 is negative 4. And then 4 plus negative 4 is 0. Okay, so this tells me x minus 1. Again, that's my 0. Right, remember it's the opposite because x minus 1 equals 0 is going to give me that x equals 1 times x squared minus 2x minus 4. Remember when we start our new polynomial that we're multiplying it by, it's always one less degree or one less exponent than the previous polynomial that we started with. So we started with an x cubed or an x to the 3rd power. So we're going to end up with an x squared to start with. I can use the quadratic formula to find the remaining 0. If you can easily factor it, go for it, factor it. okay? But if I have x squared minus 2x minus 4, I'm not going to get something that's easily factorable, okay? So I'm going to go ahead and use the quadratic equation to solve for my other zeros. So my quadratic formula again is negative b plus or minus the square root b squared minus 4ac, all divided by 2a. A equals 1, b equals negative 2, and c equals negative 4. So I substitute those values in. So I get negative 2, which is going to give me a positive 2, plus or minus the square root of negative 2 squared minus 4 times 1 times negative 4 divided by 2 times 1. Okay. Again, that negative make a positive. So I have 2 plus or minus negative 2 squared gives me 4. And then 4 times 1 is 4. So negative 4 times negative 4 divided by 2, which again simplifies to 2 plus or minus the square root of 4 plus 16 divided by 2, and then 2 plus or minus the square root of 20 divided by 2. So now I want to figure out if I can simplify the square root of 20. 20 is not a perfect square, so I'm going to go ahead and use prime factorization to figure out if there's anything I can take out of this square root. So 20 breaks down into 4 times 5. 4 breaks down into 2 times 2. 2 and 5 are prime numbers. I have a set of 2's, so they can come out of my square root. So I will have 2 plus or minus 2 times 2 times 5. Remember, I can take that set of 2's out. So I'll get 2 plus or minus 2 times the square root of 5 divided by 2. The square root of 5 is approximately 2.236. Okay. So I can substitute that value in. You can use a calculator. If you do 2 plus 2 times 2.236 divided by 2, you'll get 3.236. And if you do 2 minus 2 times 2.236 divided by 2, you'll get negative 1.236. You can also simplify this a little bit further before you substitute that value of that square root of 5 in by realizing that these 2's here will cancel out, and I'll just be left with 1. So I'll have 1 plus or minus the square root of 5 and 1 minus the square root of 5, and I'll get the same answer. So what are the real and complex zeros of the polynomial function shown in the graph? If I have x to the 4th plus x cubed minus 11x squared plus x minus 12. So this is a polynomial with a degree of 4. I can see from my graph that I have 2 zeros that cross the x-axis, okay, at x equals negative 4 and at x equals 3. I can confirm that x equals negative 4 is a 0 by substituting negative 4 in. I do get f of negative 4 equals 0. I can do the same thing with 3 to confirm that it's a 0 as well. Okay, so I do get f of 3 equals 0 as well. So they do both work. They are both zeros. Okay. I can use synthetic division to factor the polynomial. It doesn't matter which 0 you use first. Again, you'll get the same result in the end. I'm going to use negative 4 first. So I bring 1 down. 1 times negative 4 is negative 4. 1 plus negative 4 is negative 3. Negative 4 times negative 3 gives me a positive 12. Negative 11 plus 12 gives me a positive 1. Negative 4 times 1 gives me a negative 4. 1 plus negative 4 gives me negative 3. Negative 4 times negative 3 gives me a positive 12. Negative 12 plus 12 is 0. Okay, so I have x plus 4 times x cubed minus 3x squared plus x minus 3. Okay. I still have this other 0 over here, this 3. I'm going to use that to factor out even further by using that 3 with what had previously remained. So I had my coefficients of 1, negative 3, 1, and negative 3. I bring my 1 down. 3 times 1 is 3. Negative 3 plus 3 is 0. 0 times 3 is 0. 1 plus 0 is 1. 3 times 1 is 3. Negative 3 plus 3 is 0. So that gives me the x plus 4. Again, that first 0 I used. The x minus 3, the second 0 I used. and then what's left over, which is the x squared plus 1. Okay. You can use the quadratic formula if you want to solve this, or because I only have one x value and it's an x squared value, I can set x squared plus 1 equal to 0 and solve it that way. Okay. When I do that, x squared plus 1 equals 0, I get x squared equals -1. I'm going to take the square root of both sides, so I get x equals plus or minus I. Okay, so x equals plus or minus I. So I get my zeros of -4, 3, I, and -1, or negative I. Interpret the zeros of a function. So Acme Innovations makes and sells lamps. Their profit P and hundreds of dollars earned is a function of the number of lamps sold X in thousands. From historical data, they know that their company's profit is modeled by the function shown. So -x cubed plus 11x squared minus 4x minus 60. What do the zeros of the function tell you about the number of lamps that Acme Innovations should produce? So a profit for the company corresponds to the portions of the graph that lie above the x-axis, okay? So if it's below the x-axis, it's negative, which means they're not making a profit. I want to find the zeros of the function to determine where the graph crosses the x-axis. Based on the graph, the zeros of the function appear to be at -2, 3, and 10. If these are the zeros of the function, then by the factor theorem, you can determine the factors of the related polynomial. So my 0 is -2, my factor is x plus 2. My 0 is 3, my factor is x minus 3. My 0 is 10, my factor is x minus 10. I multiply these factors to verify that the product is equal to the polynomial. So x plus 2 times x minus 3 times x minus 10 gives me x cubed minus 11x squared plus 4x plus 60. What I can notice is this is the opposite symbols for what I was originally given with my polynomial. So the result is equal to negative p of x, not p of x. But both polynomials have the same factors since p of x equals negative x plus 2 times x minus 3 times x minus 10. So the zeros of the function are -2, 3, and 10. So this means when p of x is positive, Acme Innovations earns a profit. The profit is positive when x is less than -2 or between 3 and 10. Acme Innovations cannot produce a negative number of lamps, so I can disregard anything that's less than -2. Since X represents the number of lamps in hundreds, the company should make between 3,000 and 10,000 lamps. And we got that by multiplying 3 times the 100, so 3 times 100. Okay, lamps sold X in thousands, so 3 times 1,000 gives me that 10,000. Solve polynomial equations. What are the solutions of x cubed minus 7x plus 6 equals x cubed plus 5x squared minus 2x minus 24? Okay, so I can rewrite the equation in the form p of x equals 0. So basically what I'm going to do is I'm going to take everything on the right side of my equation and I'm going to move it to my left, okay, and set it equal to 0. I can combine the like terms on one side of the equation. So the x cubes, the 7x and the 2x are like terms. 5x squared gets to hang out by itself, and 6 and 24. So this gives me -5x squared minus 5x plus 30 equals 0. Okay. I can then find the roots. In this case, I'm going to factor out a 5 or a -5. So I get -5 times x squared plus x minus 6. And then I can factor x squared plus x minus 6. So you can use this by realizing that 3 times -2 gives me -6, and 3 plus -2 gives me that +1. You can use the quadratic formula if you would like to, the -b plus or minus the square root b squared minus 4ac divided by 2a. It'll give you the same results. The roots in this case are x equals -3 and x equals 2. To check, I can write each side of the equation as a separate polynomial and graph them. I use the intersect feature to confirm that the graphs intersect at x equals -3 and x equals 2. You can also graph both equations in Desmos if you have access to it and see where the graphs intersect. So again, I graphed x cubed minus 7x plus 6 as one of my graphs. That's my blue graph. And then x cubed plus 5x squared minus 2x minus 24 is my green graph. And you can see that they do both cross at x equals -3 and x equals 2. Solve a polynomial inequality by graphing. What are the solutions of x cubed minus 16x is less than 0? So the solutions are all values of x that make the inequality true. The polynomial x cubed minus 16x defines a polynomial function p of x equals x cubed minus 16x. So I start with x cubed minus 16x is less than 0. Okay. I'm going to factor to find the zeros of the function. So I'm going to set this equal to 0. So I get x times x squared minus 16. X squared minus 16 is the difference of squares. So I can rewrite it as x times x plus 5 times x minus 4. So that means my zeros are x equals 0, x equals -4, and x equals +4. I can then sketch the function and use the graph to determine where p of x is less than 0. Okay. So where the blue portion show where x is greater than 0. So it means it's above the x-axis. The pink portions show where p of x is less than 0. So the solutions of the inequality x cubed minus 16x are less than 0 are all real numbers such that x is less than -4, or 0 is less than x is less than 4. What are the solutions of 2x cubed plus 12x squared plus 12x is less than 0? I'm going to follow the same exact steps. So I have 2x cubed plus 12x squared plus 12x. So I can factor out a 2x. So I get 2x times x squared plus 6x plus 6. X squared plus 6x plus 6 does not factor easily. So I'm going to go ahead and use the quadratic formula in order to solve this. When I do, I get x plus 3 minus the square root of 3 and x plus 3 plus the square root of 3. Okay. So by the zero product property, the zeros of p are 0, 3 plus the square root of 3, and 3 minus the square root of 3. Okay. Again, I'm going to sketch the function 2x cubed plus 12x squared plus 12x. And I'm looking for the points where it's below the x-axis because it's less than 0. So the blue portion, again, show where p of x is greater than 0. The pink portion show where p of x is less than 0, which is what I'm looking for. So the solutions of the inequality 2x cubed plus 12x squared plus 12x is less than 0 are all real numbers such that x is less than -3 minus the square root of 3, or -3 plus the square root of 3 is less than x is less than 0. Our summary. So if I have a polynomial, f of x equals x minus a squared times x minus b cubed times x minus c, the x minus a, so a is a 0, b is a 0, and c is a 0. A squared, that has a multiplicity of 2, which means it has a turning point on the x-axis. The x minus b cubed has a multiplicity of 3, so that means it crosses the x-axis at 3 at that point. And then x minus c has no multiplicity. It just has a multiplicity of 1. So it also is going to cross the x-axis at that point, at that 0. And that is the end of lesson 5.